Hello students, how are you? I hope you are fine and doing your studies and continuously revising whatever the lecture we have completed and also watching the videos of other subjects. Okay, so in the previous video we talked about simple pendulum. There were certain terms related to the simple pendulum that were time period, frequency. Time period was time taken by pendulum to complete one oscillation, and the frequency was number of oscillation in 1 second. Okay, there was a term that we didn't discuss, was amplitude. Okay, it is a simple term, so let's discuss it now. Amplitude: maximum displacement of the bob from its mean position on either side is called amplitude. Getting it? Maximum displacement, that means the distance that is covered, maximum displacement. So what is the maximum displacement? O to A on either side, means only one side. You cannot say that it is A, B is the complete. Okay, the amplitude is OA. So the maximum displacement of the bob from its mean position on either side is called amplitude. Okay, then we also discussed a question related to the time period. I hope it was clear to you, because see, the questions related to simple pendulum, they are mainly based on unitary method. Okay, if you know the unitary method, then you can solve the questions easily. Okay, so the topic that we have to start today is distance time graph. So what do you mean by graph? A graph is anything that describes a particular data in a pictured form. Okay, you have drawn line graph also. You should have drawn in bar graph, and there is also pie chart that are given in some books like science. If you have seen that circular diagram is given percentage wise. Okay, so these are graphs that helps the data to be represented in pictured form. So we have to discuss today, that is distance time graph. Okay, it is very important, students. What is a distance time graph? A graph which represents the distance traveled by an object with respect to time is called distance time graph. Getting it? A graph which represents the distance traveled, means an object is traveling. So what is the total distance traveled by the object with respect to the time taken, means what time it has taken to complete that distance is denoted in a distance time graph. Okay, now we will discuss how to draw a distance time graph. Okay, so it is very important, students, so please understand it. First one is, mark the x-axis and the y-axis and divide them in equal quantities. For example, it is in graph paper. Okay, so mark a point O. It is said to be origin. The horizontal line like this, it is a x-axis. Okay, this one is the x-axis, and the vertical line is the y-axis. You are seeing that these are perpendicular to each other. See, OY is perpendicular to OX. Okay, so you get 4 quadrants, 1, 2, 3 and 4. Okay, this one. Now the values from O to the right hand side, this one OX, these are positive values, and to the left hand side, this one is the negative values. Similarly, above OY, all are positive values, and below this one is the negative value. So on a graph, we take first quadrant. This is said to be the first. There are 4 quadrants, 1, 2, 3 and 4. So to draw a graph, we take normally the first quadrant, that is OX and OY. Getting it? Again, this is origin, means the value here is 0, or this is the starting point of the graph. That is why it is called origin. O point is called origin, and here it is X and here it is Y. So the first point, mark the X-axis and Y-axis and divide them in equal quantities, because you know in graph paper there are equal at equal distances the lines are given, so you can divide them easily. Okay, second and the most important, choose one scale to represent distance. Now you have to choose, on one axis you have to represent the distance and another you have to represent the time. Okay, so for example, I have taken OY to represent my distance. Okay, I have taken this OY axis to represent the distance, and what I said, the distance that I take is in kilometer. Getting it? And the other, definitely now the other axis remains is the OX, so I am taking OX to represent time. Okay, what I did, choose one scale to represent distance and another to represent time. Now you have to give a scale. Okay, you have to fix a scale. Means according to a graph paper, that small box, okay, you know, in which very small other small boxes are drawn, one that complete box is 1 centimeter square. So this side I am saying that 1 centimeter is equal to 1 minute on time on this axis. So my scale is 1 minute is equal to 1 centimeter. So after every 1 centimeter, this will be 2 minutes, this will be 3 minutes. Okay. And similarly here on the y-axis, 1 centimeter is equal to 1 kilometer. Because distance, you need to represent the distance, no? How much distance has been covered. So according on the graph paper, the distance is fixed. So you have to give it to a scale. So the scale is written over here. For example, on x-axis, this one is the x-axis. X-axis is 1 centimeter equal to 1 minute. Okay, and on y-axis, 1 centimeter is equals to 1 kilometer. Getting it? And then you can equally divide it, as we said, divide them in equal quantities. Means 1, 2, 3. You can see the difference between them is of 1. Here 0 to 1, 1, 1 to 2 again 1, 2 to 3 again 1, and similarly over here 1 kilometer, 2 kilometer and 3 kilometer. We have to divide them equally. This is a very important to give the scale. Okay. It is not necessary that you need to give scale always, means like 1. Sometimes when the data is more elaborated or more large, so you have to, means you can also say 1 centimeter equal to 5 kilometer. For example, if it is given distance travel is 25 kilometers, so you can say 5, 10, 15. So you can say 1 centimeter equal to 5 kilometer also. Okay. It is not necessary that always you have to take the scale as 1 centimeter equal to 1 kilometer or 1 centimeter equal to 1 minute. Okay, and the unit can also be changed. It can be 1 second, it can be 1 meter. Okay, very important. So first point was mark the x-axis and the y-axis. I hope it is clear to you. This one is the positive and this one is the positive. So to draw the graph, we take this quadrant only and we leave all the other 4 quadrants. Okay, then choose one scale to represent distance. We have taken on the y-axis and other to represent time. Getting it? Where 1, and we have to give the scale also, that for 1 kilometer equal to 1 centimeter, 1 minute equal to 1 centimeter. So on x-axis time and this. Getting it? Now after choosing the scale and choosing the axes to represent distance and time, now we have to mark the values of the time and the distance in the graph. For example, data will be given to you in the form of table or maybe in the form of questions. Here it is given in the form of table. For example, distance I would rather tell you in kilometers over here, and it is in minute. After 1 minute, the distance travel is 1 kilometer. After 2 minutes, the distance becomes 2 kilometer, and after 3 minutes, the distance becomes 3 kilometers. Okay, so mark the values of the time and distance in the graph. You have to mark in the graph. Now you can say, for example, this is the OY axis and this is the OX axis. Okay. Now distance is 1 kilometer. So we come over here. Distance is 1 kilometer on the y-axis. And similarly, the time taken over here is 1 minute. So after moving here, I have to move a little bit over here to come at 1 minute. So these 2 points meet over here. So I mark a point like this at 1, 1. Getting it? Again, the distance was 1 kilometer. So I moved 1 kilometer on the y-axis. And now also the time has also increased. So you have to move on the x-axis also. If you are increasing the value on the y-axis for 1, so the value on the x-axis will also increase, because it is given 1 over here also. If it would have been given 0, then no problem. Then you would have marked the dot here. If time axis would have been here 0, 0, 1, then the point would have been here. But the distance is 1 and the time is also 1. So you have to put the point over here because the time is also increasing. Now next one, after putting a point over here, now again I will come on origin, and now let's see, distance is this time 2. So I will move again. This time here is 2 and the time is also 2. So again we will go in front of time like dot, and here this is 2 seconds. So these two like parallel to, this is parallel to y-axis, this is parallel to x-axis, and here will be a point. And similarly for the 3, 3. Okay, and after these plotting these points, we will join them with a straight line. And now after joining, you obtain a straight line graph, and this is a distance time graph. Okay, again what we did, we first mark the axes. Okay, OY and OX, these were the axes, and we divide them in equal quantities. That was the first point. Equal quantities 1, 2, 3. Then I told you we gave the scale, like over here, x equal to 1 cm. Oh, we decided for OY we took the distance, and on the x-axis we took the time. And then we decided the scale. For example, on x-axis 1 centimeter will be equal to 1 minute, and on y-axis 1 centimeter will be equal to 1 kilometer. Okay. After that, we have to mark the values of time and distance in the graph. Means according to the data that is given. The data that I have taken is here is simple. Okay. So what was the data? For example, on the first one, it was distance 1 kilometer, like this on the y-axis, and time was also 1 kilometer. So here, so these two are joined perpendicularly, and a dot is made over here. And similarly, when 2, 2, again. What I said previously also, that here that data is simple. You can just mark 1, 2, 3, 4. Sometimes maybe here it was given a distance 10, time is 0, or you can say 5 seconds. So now you have to choose different scale. You can choose 1 centimeter equal to 5 kilometer, 10 kilometer. Okay, if the distance is 10 and time is 5 minutes, again now time become 10 and here become 20. So for example, so it is not necessary that I again said that you need to take scale always 1 centimeter equal to 1 or 1 centimeter equal to 1 kilometer. Okay, it can be changed according to the question. So students, now a very important topic comes, shapes of distance time graph. Okay, we have to study 3. First one is straight line. Okay, in straight line means like this, we have studied, we just drawn it. So distance time graph, it is a straight line. What does it show? That the distance is constantly changing with time, continuously changing with time, but at a constant rate. See, at a constant rate. So this tells us that object has a uniform or constant speed. How you can say, wait, after 1 minute it is traveling 1 kilometer, and after 2 minutes the distance was 2 kilometer, after 3 minutes the distance was 3 kilometer. So we can say yes, it is moving with constant speed. That's why the distance that is it is traveling is keep on increasing at a constant rate. If it was not have been uniform speed, then after 2 it maybe have 3 kilometers, or it maybe have the distance less than 2 kilometers. Okay, but what we are saying, if it is a straight line like this, okay, then object has a uniform or constant speed. That's why it is covering equal distances in equal time interval. We can say, for example, in 0 to 1 second it travels 1 kilometer. For example, 1 to 2 second it covers another 1 second. So total becomes 2 kilometer. So this is what it has to say. Object has a uniform constant speed. What will be the speed? Distance covered, time taken, 1 by 1. 1 kilometer per minute. 1 kilometer per minute, for example. Getting it? Like this, sorry. 1 kilometer, 0 to 1. 1 kilometer, 1 to 2 seconds. Total distance, 2 kilometer. But in every equal fixed interval, for example, here 0 to 1 second, distance covered is 1 second. 1 to 2 seconds, the distance covered is 1 second. Okay, so this is what we say, object has a uniform or constant speed. Second one is when it is parallel to time axis. Now we have taken distance over here and time over here. Now the graph says it is like this, parallel to the time axis. You can say this is the time axis, it is parallel to the time axis. What does it signify, or what does it tell? It tells that it is a stationary object, or it is at rest. Means the object does not move. Definitely you can see here the time is changing on this. If I move on this line, please, if I move on this line, then is the time changing? Yes. But is the distance changing? No. Distance is this only, fixed. So it is said that after sometimes also the distance is this, and after another sometime if we see, the distance is not changing. So we can say the object is not moving, or it is in the rest position. It is a stationary object. Okay. And third one is curved shape graph. I have just drawn it. It can be any shape. Okay. Curved shape graph. And that says that object has a non-uniform speed. Non-uniform speed means it is covering unequal distances in unequal time. Okay. In equal time. For example, this time I say for 0 to 1 second, it is traveling first in 1 kilometer. Then after 1 to 2 second means another 1 second interval. It is this time it travels 2 kilometer. So the total becomes 3 kilometer. Okay. And then I say again from 2 to 3 second, it covers again this time 1.5 kilometer. So it is not moving uniformly, means the speed is continuously changing. That's why. Okay. So this is said to be object has a non-uniform speed when a shape will be curved shape. Okay, so we have studied three graphs. What was the first one? When it is a straight line. A straight line says that the object is moving with constant velocity. Then parallel to time axis. Parallel to time axis, what does it tell? It is a stationary object, or the object is at rest. And the curve shape graph tells us that the object has a non-uniform speed. Means the speed of the object is non-uniform. It is continuously changing. Okay, at every time interval. Now the next is to find the speed from distance time graph. Okay, if a distance time graph is given to you, then how you have to find the speed? You definitely know that speed is equal to distance upon time. For example, this graph is given to you. The time here, it is 5 seconds, and the distance here final. Okay, this is the final one. So how you can say the final position of the object minus initial position of the object, that will give you the distance traveled. If I minus 10 minus 0, so this is the distance traveled. Okay, if it would have started from here, then I would have subtracted 10 minus something, 2, 3, whatever it has been given. So what we have to do, final position is this one, and the initial position from the graph has started, this is the initial position. Okay, and divided by the time taken. So if here I say what is will be the speed, you say the final position is 10 minus initial position is 0, because it is at starting from origin, and what is the time taken? 5 seconds. So the speed will become 2 meter per second. Getting it? So this is important. Sometimes the graph is given to you and it asks the speed. We discussed the question related to the speed, but it was numericals. It was given in the data form. Sometimes it may be given into the graphical form, and then it can ask you the speed. Okay, so speed, what you have to do, the final position of the object according to the graph, and then minus it from initial position of the object, and total time taken to reach that position. Why? What is the time here? This one, from final position to initial position. Final position to initial position, and the answer is like this. So students, the next one is to compare the speed. Means if two objects are given on the distance time graph, then how to compare the speed. So let's take a look. If a distance time graph is given and the two objects A and B are moving. Okay, so let's say A and B are moving. Now if we, by going the graph, it is easy to look. See, the distance traveled by A is somewhat here, like this, and distance traveled by B is here. Definitely the distance traveled by B is less in compared to A, and definitely the A has taken some less time. So who will be moving faster? Definitely A will be moving faster. Or you can also say the more steeper the graph, more is the speed. Okay, what do I want to say by saying the steep? Means this angle, the angle that has graph has made with the x-axis or the time axis. Tell me, is this angle more or this angle? Definitely this angle is more. This one, complete angle. This angle is more, and this angle is less. So the angle in which it is more, that moves with the greater speed. So I can say that A is moving faster than B. Otherwise you can also look at like that, distance covered is more and time is less taken. Time taken is less for A. And here B, it has covered less distance and taken more time. So definitely it will be traveling slower. Otherwise a simple method is by looking at the slope of the graph. More the angle, faster it is moving. So A is moving faster than B. Okay students, so this was all related to distance time graph, and I hope it is clear to you. Keep studying, because all the theoretical part of this chapter is over. We have done many questions. In the next I will try to discuss the NCERT exercise. Okay, so till then complete this chapter by your side, by studying, by making notes, and by doing different questions. Okay, so students, again keep be inside your house and take care of yourselves. Thank you.